call. It's Grant. I'm making this video today to serve as a sort of conceptual introduction to and to talk about some of the guts and the reasoning behind my long-term project, which is called the GRROM, or the George R.R. Object Model, a many-dimensional knowledge graph of A Song of Ice and Fire and its associated works. This is a project that I've been working on for several years, off and on, in my spare time. It is essentially a database that combines not just one kind of data, but every kind of data that could be where, things that you could that you could store in a list and that type of thing. Today in this piece, I want to talk about the actual structure itself and what it is, why to use this, and what it gives us, basically. I'm using several items, all that are regular, common computer science items. Neo4j is the name of the graph database that I'm using. I'll get more into the structure of it, but basically that's the back-end software that's storing the actual stuff that I'm making. Then I use Microsoft Excel, which everybody knows, as it's just a spreadsheet, and I use it for spreadsheet type things. Basically, I store tabular data with it, and it's easy to interface with, and easy to share, and that kind of thing. It's an interface that everyone loves. And then I use the Python programming language to do all of the actual kind of work. So, those, and then I use several particular libraries, mostly having to do with interfacing with the database, interfacing with the spreadsheet, putting the things on a website, and then doing the actual guts of language stuff that's necessary when you're dealing with text, which is what I'm dealing with. So, as a little overview, let's talk about what a graph is first. A graph is it's often thought of as like a line chart thing or whatever. Those are charts that you often see where, like a pie graph or whatever, or a a line plot that is a type of graph, but it's better called a chart. A graph, in the sense that we use, I think of things like this, is a model of storing data and in a way that is intuitive. It consists of only really two things, which we call nodes. Think of these little circles as nodes. Each one of these represents a thing. And then the little arrows in between them, which are called vectors or relationships, or there's a number of names for these things, but basically you got the dots and you got the lines, and anything that you can make that's a model that's out of dots and lines is a graph like this. Okay, so there's an extra layer of complexity that you can have in a graph, which is to say that you can assign properties to either nodes or relationships. And in this example here, we have think of these red things as one type of node. Maybe they represent some thing or other, and then this blue one represents also a thing, but a different kind of thing, and the black ones are some other third type of thing. And then maybe we have relationships that between this thing and this thing, whatever it is, but this one, maybe that's a different kind of relationship. So the idea is that you have this structure of things, relationships between things, and then we can say stuff about the things. So that's pretty simple, right? I mean, and the thing is, it is that simple. That's all there is to it. A graph database such as Neo4j, which I'm using, holds the data in this way. There's ways that you interface with it and stuff, but it's not in some table and it's projecting itself onto this. It's literally this, in an optimized way, of course. But let's say we've got a property graph of this type. And let's add one more layer to it, which is to say, let's actually make those things mean things. And then here's what's called this turns it into what's called a knowledge graph, which is to say here's a data structure that is literally holding what we know, and what the list of things that we know about, and how they relate to each other. Let's jump into A Song of Ice and Fire here and say that we've got a character node. This one is Ned. This is the red ones. Maybe there's several thousand of them, but they're characters, right? Well, then you got a location, Winterfell. That's not a person, it's a place, right? They're nouns. You think of nodes as nouns. And here's a castle. Winterfell's a castle. It's a type of thing. A castle is not a specific thing. Maybe these are locations. They're specific things. Winterfell, the North, the Dreadfort. Those are actual names of places. A proper noun, so to speak. Well, you could also have a regular, an improper noun, or like which is to say castle, which is not any castle, or which is any castle rather than a specific castle. So maybe that's a structure, a type of structure, right? And then this type is character, and this type is location. And then you can have whatever properties you need in whichever place. Now, in some other kinds of databases, in a relational style database where it's putting tables together, essentially, you'd have to have all kinds of different little things to tie it all together, and for various reasons that have to do with computer sciencey type stuff, there are lots of limitations on how those things can be designed. Well, this has less strictures, in the sense that I could say, here's a character node, which is the exact same kind of node as every other node. The only things that's different is the properties I've put on it, right? And I've said now this one's a character. Well, what does a character have? A character has a name and an age and yada, yada, yada. All the other things that you can say about a character, right? And then maybe, Catelyn's over there and he's married to her, right? So she's got a different name and a different age, also type character, and, from a different place, whatever. Now, the locations, they don't have a name. They have a name, but they don't have an age. I mean, sort of, maybe. I don't know. I guess technically Winterfell has an age, but that's not the point. The point is, the properties that are on this thing don't need to be the properties that are on this thing. They just can have whatever they happen to have. They can have whatever they need. And if I have 10 characters lined up and I know a lot about one and not very much about another one, well, I can have a bunch of properties on one guy and hardly any properties on another guy. There's almost nothing that we actually need to start with, but we can put in everything that we have. And if we store it right, over the course of the thing, we're not really storing information any more than once. We just have it, this is Ned, and every other thing that's ever going to attach to Ned will go straight to this node, so that when we go back and search it later on, which is the real point of a database, is searching it, that we can go say Ned, and it will give us thousands and thousands of connections that make up Ned Stark, and all of the things that he's related to and all the different ways that he's related to them. Now that, my friend, is knowledge. That's why this is a knowledge graph. So, within a knowledge graph, I've identified these structures. There are better references for doing this in a more formal way that may be, more academic and have things like that. This is mostly my own terminology because this is mostly I figured this stuff out and, by doing it. So I've just made up a great amount of this. However, I do have a background in databases, and essentially, for lack of a better way of putting it, and I do understand all of this stuff on a meta level, so this isn't completely just made up. I actually am somewhat qualified to do this. So I'm not going to look at them on this sheet, but basically, there's all these different kinds of ways that we can hold stuff and ways that we can think about it, right? So first up is sequences, or when a lot of people, when they're doing analysis, they'll call it time series. Little financial data, you'll see time series analysis. This series that, basically, it's not. I think of a sequence as anything where the order matters, right? If you have a bunch of things, and there is some ordering to them where the order itself means something. The calendar, any calendar, is that type of thing, right? It's one after the other after the other. You could break it down to seconds, minutes, hours, days, whatever. But ultimately, a timeline is a linear sequence. We can put it all in one line. The other big example in this thing is the corpus. That is to say, the actual text of the book series, right? So it's chapter 1, chapter 2, chapter 3, and within that, it's line 1, line 2, line 3, right? So those will have an inherent order. Now, it may be that they are mixed up chronologically and stuff, and this timeline doesn't line straight up with this corpus. That's actually the point of this thing, is that we can hold both of these things in there. This is just a series of nodes. Node 1, node 2, node 3, node 4. And there's a relationship between each one of them that says this one comes after this one, or this one comes before that one, etc. So when we break into that set of things, we can see the whole line. And it's just inherently part of the thing. They're just nodes and relationships. So, related to a sequence, but not really, only in the sense that there is something directional about it, are hierarchies. And a hierarchy is not linear, but does have, but is directional. It has the notion of, you think of this as a scale, right? This is the way that locations are, right? You can think of it at the top level. You would have Planetos, which contains everything else, right? So everything that's contained within something else. A reporting structure at any corporate organization would be the same kind of thing, right? This person reports to that person, and that person reports to the next person, or whatever. In this case, we're looking at locations and saying that we've got that we can trace a straight line to say from the planet. We can look at the continent of Westeros, which is different from the continent of Essos, and within Westeros, we might have the Vale and the North, which are not the same thing. And we go to the north, and then we go to Winterfell, and then inside Winterfell is the Keep, and inside the Keep are the crypts, and inside the crypts is the first level of the crypts, and all the way down at the end is Lyanna's tomb. So we can go from the planet down to a very, very, very specific location by traveling one line, right? And it's and it'll never branch off. That's why we call this a strict hierarchy, right? And so there's another kind of hierarchy which also has a scale to it, in a sense. It has a direction to it. It's not a scale. In this case, it's a scale because these things are kind of smaller. They're within these larger things, right? But in the loose hierarchy, the example I have here is offspring, which is, we can take something like Jon Snow, and instead of having one parent, so to speak, he has many different relationships with numerous people, right? I mean, we could say Eddard Stark, the man who raised him, and Wyla, a rumored mother, and Ashara Dane, a rumored mother, and Lyanna Stark, a rumored mother, and whatever his relationship to Rhaegar Targaryen might be, or whatever. But the idea is that we could look at this as there's a timeline inherent. I didn't write it on the sheet, but there's a timeline inherent in this in the same way that there was a scale inherent in the other one. This is moving. This is pointing down in the direction, right? So that's as this person, is a child of this person, is a child of this person. That exists in a timeline, but it's not strict in the sense that this is exactly in this, exactly in this, exactly in this. So that's the loose hierarchy, is how I say that one. There's a third type of hierarchy, which is more complex, which is a hierarchical sequence. And here we could think of this as this is the end game of the knowledge graph, I suppose, is an event section, right? We could say that we could have a node for every single event that takes place in the story. And they would exist in two levels of relationships. There would be a hierarchy because you might have a large set piece, the Red Wedding, for example, which contains several other set pieces, a wedding ceremony, a wedding feast, and then later on in the yard. And then within one of those set pieces, you have a sequence of events that has to, that makes up that set piece, which is in the other ones. Now, all of these are beholden to a timeline in the story, which is actually moving through. They're also referencing a text, the actual corpus text that is, holding, that is saying the events, essentially. So that's hierarchical sequences. We have 2 dimensions of direction, but still, but still just nodes and relationships. All of it is just nodes and relationships, and we've built all of these things. Now, there's a couple of last ones that are easy ones that are called categoricals, and those are the ones that are just lists of things. Every kind of group of things that you can make, we can make sets of things, right? So here's just a list of characters, and each one of these would be a node, and they're just the types of characters. So you can say, give me all the characters, and there they all are. There's nothing inherently, they're all equal, right? They're just types of things. And here's just like a list of swords, right? Items that exist in the thing. Think of it as the gazetteer, right? The things that exist inside the world, the stuff, the people, the items, that type of things. And these are all like specific instances of things, proper nouns, as I said before. And then you think of non-specific categoricals, which are like the types of the things that the things are, right? So you could say species instead of characters, and say the characters are grouped as different types of species, or they're attributes of things like that. Attributes would be these non-specific character or non-specific categoricals, and that's that's the basic rundown of these things, right? Going back to this, where we can see all of this together, you can see each of these are different kinds of data that have their own sort of internal structure, but they're all still made up in this world. They're all still made up of the same stuff. If I were to do this as just tables referencing each other, it would be a nightmare. But in all of these different things, and all of these different kinds of things, there are just nodes and relationships making it up. It's just how you arrange them. And what my project is, in a nutshell, is taking everything that everybody's collected and everything that we know and all the actual pieces of data that can be found and put into one of these forms that is sort of sensible, that this could all be shoved up into one place, and we could and instead of just searching the text, we could search for text amongst some other thing. Like that we could say, like I said, that we could just say, give me a character, and it would show everything about it, not just where they come up, but where they live, what they do, what they did, all of those things. At its finest grain, you could sit there, and this will have millions and millions of nodes, and you could sit there and just kind of move from one to the other and trace through this entire spider web of knowledge. That's all I'm going to talk about in this video, and others I will go through different pieces of this thing. But that's if you're not familiar with graph databases and graph database structures, I hope that this will serve as a basic, hopefully understandable overview. And as I said, I'll make more videos that will go into more specifics, and well, I'll just kind of take it as it comes. Thank you very much, and I will speak to you in the next one.